Hey everyone, and welcome to this explainer. Today, we're pointing our telescopes up to the stars and taking a pretty hard look at a grand, highly romanticized sci-fi dream. You know the one. The idea of humanity escaping our pale blue dot to become this grand, multiplanetary species. We hear the hype all the time, right? From billionaires wanting to colonize Mars to endless headlines promising us that Earth 2.0 is waiting just a few light years away. But today, we're going to ground those soaring dreams with a pretty heavy dose of scientific reality.
Okay, to kick things off, I want you to think about a question I saw pop up in a Reddit discussion. It's so simple, but it really shifts your perspective. Is outer space designed to kill us, or are we just not designed for outer space? It's a brilliant way to just instantly shatter the illusion that colonizing the stars is going to be a breeze. Because as you'll see, the universe isn't actively hunting us down. It's just that our squishy human biology evolved for one extremely specific, perfectly balanced environment.
Okay, let's dive right into this. Section 1. The Myth of Earth 2.0. Now, we're always hearing about the habitable zone, or the Goldilocks zone, that magical region around a star where it's not too hot, not too cold, so you can have liquid water. Sounds like the perfect place to search for our next home, right? And hey, since 1992, astronomers have confirmed a staggering 5,539 exoplanets. Just let that number sink in for a second. It offers this tantalizing promise of billions more across our galaxy. But before you start packing your bags, you really need to understand that almost all of these so-called Earth 2.0s are actually a total real estate nightmare.
Here's why. Our sun is what's called a yellow dwarf. It's nice, stable, and perfect for fostering life. But yellow dwarfs are actually incredibly rare. They only make up about 10% of the galaxy. On the flip side, a massive 75% of stars are red dwarfs. And here is the catch with red dwarfs. They're incredibly volatile. They bombard their neighboring planets with radiation flares up to 1,000 times more powerful than the ones from our sun. That is a life-sanitizing dose of X-rays that can literally boil off liquid water and strip away an entire atmosphere.
And it gets worse, because red dwarfs burn so dimly, their habitable zone is pulled way in closer. And when a planet orbits that close to its star, it becomes tidally locked, meaning the exact same side of the planet always faces the star. There's no day-night cycle at all. You're left with a world of permanent, scorching, desert-creating day on one side and a freezing, endless night on the other. Any moisture in the air would just drift over to the dark side and permanently freeze into solid ice. It makes these planets utterly dry and just devastatingly uninhabitable.
Moving right along, Section 2. Space wants to kill you.
So the planetary real estate market is grim, and frankly, just traveling there is brutal. The physical toll of spaceflight is terrifying. In zero-G, calcium rapidly bleeds out of your bones. Your bodily fluids shift upwards, making you feel like you have this permanent, terrible head cold. NASA has actually tried to combat this with bizarre solutions like pressure-altering sleeping bags, literally nicknamed sucky pants. Yeah, sucky pants. Then there's the radiation. A 3-year trip to Mars would expose an astronaut to 1,650 millisieverts of radiation. For context, that's the equivalent of over 16,000 chest X-rays. Medical experts have actually compared NASA's approach to this radiation risk to how the NFL handled concussions. It leads to severe neurotoxicity and cognitive decline. It's quite literally the CTE of space.
Now we've got to address the elephant in the room. Billionaires are always talking about sending 1 million people to Mars to create a multi-generational space colony. But a colony inherently requires a second generation, right? So what about having kids?
Well, the crucial point is this. There have been 0 successful mammalian pregnancies in space. 0. Not even mice have successfully reproduced in orbit. Every single step of human reproduction, implantation, fetal development, delivery, it all evolved strictly in Earth's gravity. Sending 1 million people to Mars right now with the expectation that they're going to reproduce raises massive biological and ethical unknowns. Some scientists argue it would be like intentionally having babies in the middle of Chernobyl. We simply don't have the data to prove it's even possible.
Which brings us to Section 3, Surviving the Alien Dirt. Okay, let's play devil's advocate. Let's say you survive the radiation, the muscle atrophy, and you somehow make it to a place like Mars. Surviving off-world requires a massive logistical effort known as In-Situ resource utilization, or ISRU. Basically, living off the land, because it is way too expensive to launch all your water and fuel from Earth. Take SpaceX's plan, using a Sabatier reactor. The goal here is to mine Martian ice for hydrogen, suck CO2 from the thin Martian air, and then bake it all into rocket fuel and oxygen.
It's an absolutely incredible feat of engineering, but it requires a solar farm the size of 20 football fields just to power it. And remember, Mars gets dust storms that can last for months, blocking the sun. A single failure in this complex reactor, or just a buried solar panel, means you don't have fuel to get home. You are permanently stranded.
And the numbers required for this kind of survival are just staggering. Like, if you want to extract water on the moon using local resources, you would need to bake 6 entire tons of lunar regolith. That's the lunar dirt, just to get a measly 3 kilograms of drinking water. 6 tons. And that doesn't even account for the water you'd need for growing food or, taking a bath.
And speaking of dirt, let's burst the sci-fi bubble of easy space farming right now. Martian soil is actively hazardous. It's so tricky that NASA's Spirit rover literally got permanently trapped in it. Plus, it contains a 1% concentration of perchlorates. That might sound like a tiny amount, but it makes the soil 400,000 times too toxic for human biology. It can absolutely destroy your thyroid function. On top of all that, the dust is jagged and sharp. Breathing it in causes severe lung scarring. You can't just go and plant a potato in this stuff. It has to be aggressively and perfectly filtered first.
All right, Section 4, Deep Seas and Extremophiles. So the macro universe is pretty lethal. But what about the microscopic level right here on Earth? To understand how life might survive elsewhere, scientists study extremophiles. These are life forms possessing highly adapted biology that lets them thrive in insanely hostile environments. We're talking extreme radiation, pressure, salinity. There are these ancient microbes, like Haloarchaea, found in hypersaline lakes on Earth that scientists literally sent to the outside of the International Space Station, and they survived. They survived massive UV radiation and simulated Martian conditions for 18 months. It's incredible biology that really pushes the limits of life as we know it.
When you look at our human fragility versus that extremophile resilience, I absolutely love this quote from Douglas Adams. He wrote that it's like a puddle waking up one morning and thinking, this is an interesting world I find myself in. Fits me staggeringly well. Must have been made to have me in it. I mean, it beautifully and philosophically challenges the arrogant idea that the universe was tailor-made for us. It wasn't. We just perfectly adapted to our specific, comfortable, earthly puddle.
But the puddles of Earth can definitely teach us how to explore the cosmos. Take Earth's deep ocean trenches, the Hadal Zone. They are incredibly similar to the subsurface ocean of Jupiter's moon Europa. Both have absolute zero sunlight. And because of the gravitational differences, the crushing 130 to 260 megapascals of pressure in Europa's 100-kilometer deep ocean perfectly mimics the physics found at the very bottom of our own oceans. This is exactly why NASA trains aquanauts off the coast of Florida right now, and why they test autonomous drones in deep ocean trenches. If a machine can survive the crushing darkness down here, it might just survive Europa.
And that brings us to Section 5, Searching Our Own Solar System.
You see, instead of banking on an impossible multi-generational exoplanet colony, there is genuine and profound scientific discovery happening right next door, in our own solar system. Just look at the JUICE mission. That stands for the Jupiter Icy Moons Explorer. This is a 5,300-kilogram behemoth of a probe equipped with ice-penetrating radar. Its whole mission is to autonomously scan Jupiter's frozen moons, places like Ganymede and Europa, to peer right beneath their thick icy shells, looking for those massive subsurface oceans and the potential for alien life. And the monumental human effort required for this? It is staggering. It took 11 years of development, the collaboration of 18 different countries, and billions of dollars of technical expertise, just to build this single machine and successfully launch it off the ground. That is the reality of space exploration. It's painstakingly slow, precise, and brilliant work. So when JUICE and our next-generation telescopes actually scan the stars, what are they looking for? Well, it's not a sci-fi utopia with green grass. They're looking for biosignatures. These are the subtle chemical footprints of life. They might look for gaseous signatures, like unexpected methane in an atmosphere, or temporal signatures, like seasonal oscillations of carbon dioxide. They even look for surface signatures, like the unique light reflectance of ancient microbial pigments that might literally make a planet look purple from space. That is the real hunt for alien life.
To wrap up this explainer, I really want to leave you with a provocative thought that grounds us right back here on Earth. If we are struggling to maintain the perfect, beautiful puddle we already live in, what makes us think we can easily engineer a brand new one out there in the brutal, lethal vacuum of space? Escaping our home just isn't the easy backup plan that sci-fi makes it out to be. Honestly, it leaves you deeply appreciative of our own pale blue dot. Thank you so much for joining me on this journey today. Keep looking up, stay curious, and I'll catch you in the next explainer.